Hello, everyone. My name is Merima, and I'm a community manager in our Sarajevo hub. I will be your host today together with my colleague Slavica. Bojan will be our presenter. And yeah, before we start, I would like to say welcome from all our hubs, Sarajevo, Belgrade, Skopje, Novi Sad, and Niš, because we are all here. And we hope you will have an awesome 1.5 hours spent with us. I will hand over the mic soon to our presenter, Bojan. He's the star of the night. But first, Slavica will introduce herself.
Hello guys, my name is Slavica. Merima already introduced me. I want to say that I'm really happy to see all of you here, and I think that this will be a really interesting experience for you. Besides the cool presentation that we have and that Bojan will deliver, we will also have some cool quiz after the Bojan presentation. So stay tuned, and we prepared a lot of great prizes for you. Also, after the whole meetup thing, like webinar thing, Merima will send a follow-up where you will have some task or the game you can complete, and then we prepared also a lot of cool prizes for you. So a lot of things is happening. We have funny part, we have a knowledge part. Also, don't hesitate to be in discussion with Bojan, to ask questions and talk with us. That's it by my side. Bojan, are you ready?
Yep. Yeah. So let me share my screen. Yeah, can we see the screen?
Yes.
Perfect. Okay, so welcome everyone to the talk about TensorFlow and machine learning for JavaScript developers in general. We're my perspective and what I wanted to achieve with this talk has shifted over the period that I was preparing it. So now it's made in a way that I want every developer here to be able to make something useful with machine learning and TensorFlow and another library we're going to be using after this talk. So I hope you pick up some decent knowledge. Okay, so a little bit about me first. I've been at Symphony for approximately a year. For my entire career, basically, I've been working mostly as a React developer. Other than that, I worked with some VR stuff and augmented reality as well. I worked on some mobile apps with Flutter and React Native, but 95% of my skills are around React. And as it says here, I have a knack for learning things that pretty much end up completely useless. So I hope machine learning won't be one of those, but time will tell. So it's kind of strange to have like a webinar and a meetup where I can't see the audience and I can't see there's not much interaction. So to kind of break that cycle, there will be a poll now regarding your knowledge in machine learning, and if you have any experience with it and if you want to do it in the future. So Slavica will start the poll, I think now.
Yep.
Yeah. So yeah. So while you guys answer the poll, if you also have any questions in the chat, you can ask. And yeah, let's start. So here's what we will be covering throughout the talk. First, what is machine learning in general in layman's terms, because it's kind of a big subject and we need a simple way to understand it, to know what's going on. After that, we will be covering general applications for machine learning, so the ways we can use it to our advantage. We will go over some machine learning terminology that will be required for us to actually understand the terms and to know what's happening and what we're talking about. We are going to talk about the 4 different types of machine learning that are currently practiced. One of those is inductive learning, and we're going to go deeper into that, and that's what we will be using in our demo application. After that, we will switch over to TensorFlow. So talk a little bit about that open source project and what it gives us and what are the possibilities. After that, we're going to talk about ML5.js, which is a library that we're going to be actually using today in our demo app. It's built on top of TensorFlow, so it's pretty much the same thing, like it achieves the same thing. After that, we're going to be training a new model, and putting that model to use within a small React app. And then we will go over to some other examples of machine learning that are available on the web and see how other people implemented it into their own apps and websites. And in the end, we're going to share some resources where you can actually find trained machine learning models that you can use in your own apps, because people have created models for basically everything already. So it's very rare that you need your own. And in the end, we're going to talk about the impact of machine learning on development and on like everyday life and its consequences. Okay, so let's start the talk officially. So let's cover what machine learning is. Well, you can think of it as the simplest way is to think of it like computers programming themselves. So in traditional programming, we combine software and data to get a certain output we need. And in machine learning, we provide the algorithm with data and the desired output, and we get like the link between output and the data. So the more data we give it and the better we describe our output, the better the software we will get back. And since there are not a lot of developers, like not enough to fill all of the needs, machine learning is a great way to bridge the gap and solve the bottleneck that we have as software developers and makes writing software more scalable. Okay, so the general applications for machine learning, which there are many, but let's cover some of the most popular and more the ones that we can see the easiest. So the first one would be web searches. So you probably use them every day. Stuff like Google or like eBay or Amazon searches are all backed by machine learning. Computational biology, this is a big one that most people don't even know it is like machine learning is used in. Since the companies that create our drugs need to run a lot of experiments, they started using machine learning to transfer the knowledge basically between experiments, so they don't have to start all over every time. So the next sector where it's important is finance. So companies can use it to decide who to send like credit card offers to, or check if a certain investment is good or not based on previous experience and stuff like that. We will talk about the finance sector a bit more in the future. In e-commerce, so machine learning can be used to predict customer churn, or it can be used to track fraudulent transactions. So for example, PayPal has this implemented where they check all transactions before they happen, and based on previous experience of fraudulent transactions, they check if your transaction is fraudulent or not. So if they find it fraudulent, it will not go out at all. So space exploration, this is a cool one. So it's used in space probes and radio astronomy. So regarding radio astronomy, this is a cool story. So there are satellites that are listening for radio waves all around the universe, and the data that we have about radio waves, we fed it into the machine learning algorithm, and now we are listening for radio waves all throughout the universe to see if there's somebody else transmitting radio waves. And the machine learning algorithm helps us distinguish between dummy data and like data that's not extraterrestrials from data that is. And in space probes and like the Mars rovers, machine learning is used to actually teach them how to drive themselves in uncertain areas. So that's what robotics is all about. So you can also think about Tesla self-driving cars and how they drive themselves so well. So those are some general applications. There is also debugging. So there are already some plugins for certain code editors that give us suggestions based on the code we already wrote, what we should write next, and also that help find bugs in our editors directly. Also in social networks, you can only imagine how much data companies like Facebook or Google have. and not all of that data is valuable to their advertisers. So they need some way to filter all of the data and only extract stuff that is valuable to their own customers. So it would be impossible for a person to go through all the data. So machine learning does that for them. And information extraction. So basically, if you know what type of data you want to extract from all around the web, it would be very hard for you to filter between the data that matches the pattern you want and the one that doesn't. So machine learning algorithms can really help with that. So next, we will go over some machine learning terminology. So first is the model. This is something that we will be mentioning a lot during the talk and during the demo of the app. A model, you can think of it as an algorithm, basically. It's what we get that will make the difference between our data, and that will, when we input new data, it will tell us if the data matches something we already trained it on. So in the end, it's basically a JSON file, and it recognizes some patterns. So at the moment of initialization, when you first create the model, it's basically empty. It can't make any good conclusion or any conclusion at all. And when you provide it with data, it can learn from it. And based on the data you provided and the outputs you provided in certain machine learning types, it will make better and better conclusions. So the more data you give it, the better its conclusions and pattern recognition will be. So next is supervised learning. So this is where a program is trained on a predefined data set. Supervised learning is something we will be using. So we already know approximately what type of data will be given to the software, and we know more importantly what kind of output we want. So it's much easier to train an algorithm when you have a desired output. In unsupervised learning, however, we don't have an output, and we only want the algorithm to make relationships and guess basically the patterns inside the data we give it. It's not completely automatic because there's a lot of fine-tuning involved, because there's a problem that a lot of unsupervised learning is not good, because if you have no idea what kind of output you want, it's easy for the software to start going its own way, basically. And next we have classification. It's a subcategory of supervised learning, and it's the process of taking some sort of data or any kind of input and assigning a label to it, basically. And the classification is something also that we will be using in the app, so it's necessary we know what it is. So imagine if you had to recognize a certain sound or an image or a part of a video, you would use classification to assign a label to the input. So here are the 4 different types of learning. We have first supervised learning. We already talked about it a little bit. It's also called inductive learning. So we already said that the training data includes desired outputs. So we know what we want to get out of the algorithm. Unsupervised learning, there are no desired outputs. And as I said, it's hard to tell what learning is good and what isn't. There's also semi-supervised learning. This one's kind of strange in that you may know like a certain percentage of the outputs you want, but you also you are open for a different kind of output or something similar to what you already have. So you're going to use a combination of supervised and unsupervised learning, and the results from the unsupervised learning will be fed into your supervised learning model and enhance it basically and make it work better. And finally, we have reinforcement learning. This is the most promising one and the most ambitious one. It will definitely be used like in the advancement of AI algorithms. The easiest way to explain reinforcement learning is basically through a chess game. So if you have a chess game and you want to teach the computer how to play it, but you don't want to tell the computer how chess is played, you will reward it when it makes the right moves and punish it when it makes the wrong moves. And the goal of the algorithm is to obtain as many rewards as possible. So over time, the more you reward it, the better it will get, and it will understand how to play the game over time, even though it doesn't understand the rules at all. Okay, so let's go a bit deeper into inductive learning or supervised learning. So you can think of inductive learning as, for a certain input, let's say the input is marked as X and output samples F from X. The problem is to estimate the function, or how to get to a certain conclusion from a certain type of data. So we want basically to map the data to the outcome. That's what we need. So some examples for inductive learning would be, for example, credit risk assessment, where X or the input would be, let's say, a person's credit score, and F from X would be if they should be given new credit or not. Or for example, in a disease diagnosis, let's say we can put in the patient's symptoms and we would get what disease they have as F from X or the output. Facial recognition, imagine if we put in, I don't know, a bitmap of somebody's face, we would get their name as the output, and we need to find the process, so F from X. And automatic car steering, let's say X would be the road, or a bitmap of the road, and F from X would be how much the steering wheel needs to be turned for the car to follow that road. So when should we use inductive learning? There are 4 scenarios, and all are pretty much equally important. But yeah, let's start with the first one, problems where there is no human expert. So this is pretty self-explanatory, because if there is no expert in the field, there is no way to write like generic software as a solution. Tasks that humans can perform but can't describe. So think about riding a bicycle or driving a car. So you know how to do it, but can't really describe it in coding terms. It would be really hard. Problems where the desired function changes frequently. So you can imagine like something really volatile, like the stock market, where it's impossible to write one piece of code that will always be useful. And problems where each user needs a custom function. So maybe stuff like Amazon recommendations, where every person has different preferences and you can't really use the same piece of code for everyone. So let's jump a little bit into TensorFlow. So what is it? It's an end-to-end open source platform for machine learning, and it allows us to do pretty much everything regarding machine learning. It's also one of the biggest communities for it. So there is a lot of community support for all of the frameworks and everything tied to TensorFlow. They also have a really big library of models, which there will be a link to in the resources section. And what's the main gist of it? So it allows us to train new models from scratch pretty easily. Although in this demo, we won't be using TensorFlow to train the models. We will use the Google teaching platform, which is a bit faster. And since we're on a time limit, it would take much longer with TensorFlow itself. It allows us to retrain existing models. That means that, for example, if you want to start a new model and some other model already resolves your problem or covers the needs that your model will cover too, you can use TensorFlow to like take a subset of the solution of another model and put it into yours. So that means that you can really speed up the development and training of your models using TensorFlow, and it allows us to put existing models to use easily. So we will go to ML5.js next. So this is a library built on top of TensorFlow. It has a really small learning curve. It's intuitive in a way that if you know the basic terminology of machine learning and in general its most common uses, so image recognition, audio recognition, text recognition, stuff like that, it will be extremely easy to use. And that in turn allows us to whip out applications for either Node.js or web environments really quickly. So after this talk, you will be able to create an image recognition app or an audio recognition app extremely easily. And the good thing about ML5, well, I would say it's a good thing, is that you don't really have to know the entire science behind how machine learning actually works, or how even TensorFlow works for that matter, because TensorFlow in itself is a pretty complicated library and allows us to do much more stuff than ML5. But for this demo, we're going to stick to ML5 pretty much exclusively because, as I said, of the time constraint. And I want everybody to be able to walk out of this talk with like a practical knowledge that they can instantly use in their own apps. So here, we're going to get into the practical part of the talk. So first, we're going to train a new model. We will use the Google Teachable machine platform, as I said. And we will get familiar with the platform, how we can use it to train new models, and we will see what kind of models we can train with it. We will make a model that will classify images depending on the content, and we will check what the output of the model looks like. And we will talk about some use cases we can make with image classification. Okay, so let me find Chrome. Oh, right here. Yeah, so this is the Google Teachable machine platform, basically. So this is the home screen you will be greeted it when you first come in. You can create a new project. What it currently offers is pose detection in images of humans, audio training, and image. So we will use the image project for our image recognition app, and I prepared some images. So what we're going to be doing is making a difference between cats and dogs. So let me first actually explain everything in this screen. So classes, you can think of a class as a certain type of object you want to recognize. So in our case, it would be dogs and cats. So we will name them appropriately. Yeah, here you can use the webcam to give the app input, or you can upload your own images. You can also add new classes if you have more options that you want to cover. Also here, this part is pretty important. So epochs are how many times each image will be looked at in this case, or if it's audio, how many times the file will be listened to, basically. The batch size is how many images it will look at once, and the learning rate, it will only increase the amount of time that the algorithm is actually looking at an image in this case. So basically, if you increase the learning rate, it will take much longer to train your models. So we're gonna add the images I prepared. So here we have cats. And let's upload the dogs as well. Yeah, there we go. And we click train model. It should be extremely fast with our current settings, but it should be also precise enough. So tweaking all of these will have a big influence on how well your model does and how well basically your algorithm performs and how long it takes for the algorithm to train itself. So here you can test.
Sorry, Bojan, I will interrupt you. Maybe you are missing it, but your class for cats is dogs. So just like.
Oh, thanks.
No problem.
Yeah, there we go. Thanks, Laitza. So here, when the model is actually trained, you can choose an image to test your model. So if we upload an image of a dog, it should show us, okay. Yeah, this dog obviously looks like a cat. So let's try another one. Okay, it switched probably. Oh yeah, because it was switched before I trained it. So now it should work fine. Slavica, you were a little bit late on the tip. Yeah, now it should work fine. Yeah, here we go. So we can see that there's a dog in the image and the algorithm gives us the output that it's 100% a dog. So what you can do next is export the model. Here you have the option to use it in TensorFlow.js or TensorFlow for Python. You can upload it with a shareable link or download it for yourself. So the easier solution is just to upload it to the Google and be done with it. You also have the options, if you're going to use P5, you can export it that way. So we will upload the model and we just get a link once it's done where we can use it. So that's basically it. If you want to train something other than an image, you can use it also, this platform, as I said, for audio and post projects, and they also have a lot of stuff coming up. I believe by the end of the year, you will also be able to use many different things. Okay, so next, we're gonna go and use the model in an app. So what we're going to do, see how ML5 can be implemented in a small React app. And we're gonna implement our model and fetch random images from the web and classify them using our model. So basically, let's show the app right now. So we are fetching random images of cats and dogs, and the software is giving us confidence, how confident it is, what is in the image. So a small disclaimer here, for the fetching of images, I used two services. One is called Dogs as a Service, and the other is called Cats as a Service. So it was impossible to find Dogs as a Service basically without CORS. So TensorFlow, for some reason, has a really big problem with cross-origin. So for cats, it will be impossible basically for us to show the confidence, because I will talk about actually this during the code part. So basically, we can fetch an image, it will show up, and our machine learning algorithm will show us what it thinks it's in the image and how confident it is in its choice. So basically, that's the entire app. It's pretty simple. So we're gonna go into the editor and see what we did to actually achieve this. So let me actually show this as well. So it's a basic create React app structure. So we only have one component rendering, which is the image generator. So let's get right into that. Actually, if you're interested for the API, we basically have cat and dog services here and just fetching that. So for the image generation, basically you're gonna go at it line by line. We're importing React and the use state hook. We're importing the ML5 library, our API, and the CSS that's used in the website. Here we have the link to our model, which we got from the Google service. When you make your own model, make sure to add model.json in the end, because that's where the actual data is that we will use. It also provides us with some other files there, but they are not important in actual use case. So here we have a function that just logs if the model loaded successfully or not. And here we have the classifier. Basically, this is the function that we will call and pass in data to return the confidence, basically. So we use the ML5 library here. It has a method called image classifier. It has the same thing for audio, video, and yeah, for those two, I believe. There are some more, but I'm not sure what they are used for. So we pass in the model URL, which we got from Google, and we pass in the callback function that will be called once the model is loaded. So for us, it will be just this console log. Getting into the actual React component. So first we have state, where we will store the image of the path to the image that we will be displaying. We have dog or cat state, which is basically what the software thinks is in the image. We have confidence. That's kind of self-explanatory. We will store it there once we get it. And regarding the cross-origin issue, one of the APIs requires allow origins on the image tag, and the other one doesn't. So I had to make a way to tackle both cases. So that's why we are using the allow CO state. So here we have a display answer function. Basically, when we get confidence, we get we get it for both of the classes we defined. So once we put in some data into the model, it will return so we pass it in, let's say, a cat image. It will tell us what's its confidence that it is a cat image, but it will also tell us its confidence in if it's a dog image. So basically, to display the correct answer and like what the computer actually chose, we need to make a difference to take the higher confidence and display that. So because of the cross-origin issue for cats, we will basically just be hard coding cat because there was no other way to fix it. And after that, we will be setting the confidence to 0, so it displays a new value on every image load. So here first, since we are asynchronously loading images, we need to make sure that the image we check is actually loaded. So this is what caused issues regarding course, because resources that are behind course can't be checked with onload. So here we check for the image tag that we got with query selector. Then we call the classifier with the classify method. That's basically ML5.js. Yeah, and we pass in the image tag. So it gets the data from there. And the callback function has errors and results, basically. So if there are results, since I already said it will be returning results for both cats and dogs, and no matter how many classes you defined in the actual model, it will return all of those. So here, this is a quick and dirty way to just check which ones are dogs and which ones are cats. If you have more classes, you will probably write some generic piece of code that will sort this out for you. But since we only have two, this was easy. Here we will set the confidence. Since currently the confidence only works for dogs, we are only going to pass the dog confidence. And then we will call the method that sets the state with the display answer we explained earlier, so it selects the higher one. So after that, we have the fetch image method. Basically, we want a 50% chance for it to be either a cat or a dog. So we just match random and pick one for that. So we call the API, turn the response into JSON. Then since we don't need cross-origin for cat images, we just pass in the image URL into the state. The image picks it up and displays it. We first clear if it's a dog or a cat, since the function will be running after that, and we don't want previous results getting in the way of that. And we finally call the classify method. So this Boolean here represents if it's a cat or a dog. So in this case, it's true because it's cats. And we do the same thing for dogs. So here we just have a little bit of like standard JSX. Here we have the cross-origin thingy. So in the case we don't need it, it just omits the prop, the attribute. We pass in the image URL that we are storing in the state. And here we just display the paragraphs. And that's pretty much it. I don't believe there are any other interesting files here. Yeah, that's pretty much it. So the code for this will be available on GitHub. So you will be able to get the app and extend it any way you want. It will be in the resources section. So this is a pretty simple example of what you can do with machine learning and image recognition. But if you think about this, you could be solving a lot of problems with the same method. So for example, if you had, I don't know, access to a lot of X-ray photos and scans, and you could classify them between the ones that show a disease and the ones that don't, you could actually make software that can recognize diseases in X-ray shots or like deformations or whatever. And there are a million other ways you can use it. So some people have trained models with music, basically providing the model with all of the biggest compositions from the world's most famous compositors. And the model learned how to play piano with a style that's mixed. It's like it mixes the style of all of the other performers together and plays something completely new every time you load it. I believe that example can be found on the TensorFlow documentation. So if you're interested in that, check it out. So let's go back to our presentation. Yeah, so let's talk a little bit about more examples of machine learning on the web. So you have the recommendation engines of Amazon and Netflix. We already talked about Amazon a little bit, but basically, depending on what you view and what you buy, you will get certain recommendations suggested to you. That's obviously achieved through machine learning. So it would be impossible for like a generic piece of code to make good predictions for everybody who uses Amazon. And for Netflix, it's the same thing. Everybody has different preferences for shows and for movies. So Netflix also uses machine learning to give you good suggestions. Google and Microsoft have implemented image recognition on their websites. So Google, if you heard about Google Photos, which you probably have, it's basically a service that lets you store your own photos and share them. The interesting thing about it is that it has a search bar that will allow you to search for stuff in your own photos, even though you didn't tag it in any certain way. So for example, if you wanted to find all of your photos next to a river, you could just type in river into the search and it would give you the correct result. So one bad thing about this is that all of the apps you upload by default will be going through a machine learning algorithm. So if you don't like your privacy basically being invaded a little bit, you shouldn't use Google Photos. So Google Docs, it has a natural language processing. So basically, everybody here probably sent an email using Gmail. When you're typing, suggestions are coming up as you type. And the cool thing about it is that if you're using like a formal type of language, it will suggest more formal words because it learned from other emails that were sent. And if you are having like a more personal or relaxed type of conversation, it will suggest you less formal words. In the last example, we have Twitter bot detection. So this one was really cool. In 2016, during the US elections, Twitter started using machine learning to ban bots. So what they were doing, they were looking at the region where the bots were created, what kind of messages they were sending, what time of the day they were active. They were also looking at who they were following and who they were retweeting. And the model actually found a really reliable pattern to match it to other accounts. So what they did was basically run the model through everybody, through every account, and check if it matches the pattern they found with the bots. And if it was over a certain confidence limit, they were just automatically banning all of the accounts. So here are 3 resources where you can find already trained models for your apps. So as I mentioned, the TensorFlow hub.dev, they have pretty much everything you need. Also, TensorFlow will allow you to transform models that were written, for example, for Python into models that you can use with JS. Like extremely easily. Also, Microsoft's Azure AI allows hosts a whole different set of models that you won't be able to use with JS, but maybe you can combine it with TensorFlow and like transfer them into ones that you can. And also, since TensorFlow is open source, a lot of people have provided their own models for free use, so you can find those on TensorFlow's GitHub in /models section, and there are plenty of them, and you can really create really powerful apps using other people's models because, for example, there are models, so we trained our model with like 100, 150 images maybe, and there are models that were trained over 15 or 20 million images, so you can imagine how good they were, since our model was able to recognize dogs with like 90% accuracy overall. And you can use that model also for knowledge transfer. So as we said, TensorFlow allows us to take certain chunks of the models and transfer them into our own. So if a model was trained on 15 million images, it can basically classify anything you want. So you can use that knowledge in your own models. So in the end, let's talk a little bit about the impact of machine learning on everyday life and development. So one of the biggest things, at least for me, that was the most interesting and the most promising was curing previously incurable diseases. So Elon Musk's company called OpenAI and DeepMind are working basically on a chip that will be inserted into your brain. But that sounds like sci-fi-ish, but it's really cool in a way that so diseases in your brain can cause certain parts of your brain to malfunction and not work correctly. And for example, people that have lost the ability to move one of their limbs, like hands or legs, basically there is no way for signals of the brain to arrive to the part of the brain that controls the limbs. So what this chip does is basically sends electrical signals itself to the correct part of the brain, thus jumping over the problem basically and allowing people to will allow people to move their legs or hands accordingly. And also, for example, for Alzheimer's, we know that some parts of the brain stop working correctly, and like the DeepMind chip could be used to cure it as well. So that's one really big benefit for us. There are also some negative things like privacy and security online and offline will be really threatened. So for example, we used machine learning to recognize dogs, but any government can use machine learning to recognize you. And the more times the security cameras see you, the better they will be at recognizing you and tying your face with your name. So that can lead to like a really Orwellian society, I guess. But yeah, also privacy and security online are threatened because imagine how much value out of data Facebook can get, basically, or any other like online social network. When the machine algorithms get really good, the more valuable data they will be able to extract from your own. So privacy will like really be eroding over time as machine learning and computers in general get better. So another big one is that fraudulent content will be impossible, like completely impossible to separate from real content. So as we saw on the Google Teachable platform, we could input audio to train the model. So what some people have already done is take, for example, I don't know, Joe Rogan. He has like over who knows how many hours of audio online, and people have used all of his interviews and all of his audio and fed it into a model, which in turn resulted that the model can speak and use terms exactly as Joe Rogan, and the sound is you can't really make a difference between like the original Joe Rogan and the stuff that the model is actually providing. So if you're interested in that, you can check out deep fakes, and people have done it with all of the people that have a lot of their audio online. The same thing can be done with video and photos. So it is a really big threat because somebody could create a fake video that would be like 100% look 100% authentic, and the voice would also sound 100% authentic, but the content in it would be completely fake. So if you take, I don't know, some really important politician or like state leader and fake their speeches, it could lead to some big problems worldwide. And finally, overall productivity will increase definitely as machine learning gets better. For us as developers, I'm not that worried that machines will replace us, at least not in the near future, if something doesn't like radically change. I believe though that we will more and more be using it in our daily like development, because there are a lot of menial tasks that we can speed up using machine learning, and also that can happen in a lot of different industries. So basically any job that has a pattern can be basically solved with machine learning and just sped up. It will definitely cost some people their jobs, but it will be very hard for machines to make conclusions on the data they get. They will only know how to make relationships between data, but our brain is still needed to make something out of the data we get as output. So, and here it says, Bill Gates once said a breakthrough in machine learning would be worth 10 Microsofts. So that's how much he believes in it. And we have like a more doomsday saying from Elon Musk that there is always some risk that in actually trying to advance friendly AI, we may create the thing that we are concerned about. So he's much more careful regarding AI development, and that's one of the reasons why he started his own OpenAI company. So he could be part of the race and maybe create something that will actually be good for us humans. So here are the links to the resources. They probably don't mean anything like currently, but the presentation will be available after. You will be able to go and look everything we used in the app. Also, the app will be available on my GitHub. I think it already is. I don't know if I pushed everything, but I think I did. So you will be able to get the app and do whatever you want with it and maybe create something new. Yeah, so thanks for paying attention, I hope. If you have any questions, feel free to ask in the chat, or I think there's actually a real
I think the chat
panel.
is fire, but basically this topic is like triggering everyone, and there's already a lot of questions. I don't know if you want me to read it or you will go through it and answer everything.
Yeah, I'll answer it when I go through all of them. Need to drink some water first.
You did a great job.
So I'll stop sharing the screen now. And Slavica and Mirima can take over, right?
Yep. We can read out your questions.
Yeah, there are plenty.
Yes, the first one is from Alan. Just scroll up.
Yeah, I found it.
Okay.
How are we avoiding corner cases in JavaScript? So basically with TensorFlow, when you're training the model directly, you can train it after every epoch or basically after every batch of data you go through. So, and you can apply how much change you want the model to get. So basically, you can there's a property called weight in every class and every model. So you can change the weight depending on the direction you want the model to be going in. So and the corner cases are also solved by providing enough like input and output. So if you provide like, I don't know, 10 million images of dogs, it will be really hard for a mistake to happen because it will have a lot of previous experience. Does TensorFlow have some restrictions since JS is a single core programming language? Obviously, it will be slower than using something else, but since a lot of the models can be reused from other resources and other languages, it's not that big of a deal. Okay. Why use TensorFlow.js when we can use TensorFlow in Python? Well, you know, JavaScript developers want JavaScript libraries for every single thing. So, but I also think it's cool that we can use it in the web whenever we want to. Also, not everybody knows Python, and I think, or every other language basically. So I think it's important to have options in general. And yeah, with Python, it would be extremely hard to use it in node environments or browsers or any other thing. Can we make a chatbot in TensorFlow? You could. Basically, all you would have to do is make models that recognize text, and depending on the outputs, program your chatbot to have appropriate answers. Also, using the Google Teachable platform, the next thing they will be adding is text recognition. So you will be able to pretty much have the bot generate its own answers depending on the question. Here, oh, this is when I made the mistake. So yeah, the dog image was in the actual initial array of dog images, but since the names were swapped, it showed the wrong answer. Question, why are connets a good architecture? Actually, I haven't done too much research into that, so I can get back to you after if I find out something more about it. Okay. Yeah. how do you know that your result of 99.99 is not overfitting? Well, basically, it might be, but that really depends on how much you train your model. So if you train your model with, I don't know, 10 images, the data will be, like the confidence will be very uncertain because it doesn't have enough previous experience. So I don't know, if I wanted to find a difference between a dog and a wolf, it would show that it's probably a dog even though it's a wolf. So you need a lot of data to have really reliable models. Can this be done with any popular JS framework? Yes, it can. ML5 and TensorFlow are completely independent of any framework, so you can use them anywhere. In the end, all of those frameworks generate regular HTML, so you can always use the standard ways to either get the images or the audio or the video. What classification metric are you using in the previous demo app? So basically, it's just confidence that the model provides. So the Google Teachable platform image recognition thing, the output is only confidence, and that's what we're using to check how confident basically it is that it's what we want. Can we use TensorFlow for automation testing? You probably could write some kind of tests with it, but one of the things I can probably envision it in being used is, for example, screenshot tests or something like that, where image recognition can come in really useful. So if you feed a lot of images of your app and something drastically changes, you can find issues like that easily. Note to myself, if I ever talk at a workshop, ignore chat window. Yeah. Okay, this is an answer. AI is new electricity. Yeah. Okay. What was a cool project that you have personally applied ML to solve a problem, and what was the problem? So I used it only in one personal project, and it was again image recognition. So I was working on an app that it was basically for video games, and depending on some I don't know, a map being I don't know how to describe this. So basically the game has a map where the character can move, and I was looking for the optimal way for the character to move to get to the end the fastest way. But other than that, I haven't used it in any like big projects. Which programming language is best for AI? Does depend on the application. Python is by far the most used, the most community supported, and probably the fastest in doing that. So I would, my goal was to get really good at machine learning and like data science in general, Python is by far the best language to use. And for JS, it's just a commodity we have. Yeah. Are there any other questions? Or something that needs more explanation or anything?
Write them now. Okay, you have more. How
do you comment that AI already beat humans in StarCraft and Dota? Yeah, I watched that. So it's kind of scary. The same thing also happened with the Chinese game called Go and chess. So basically there were some, like, since I play chess a lot, I can talk about that more. There were some openings in chess that were standard practice for like hundreds of years, basically. And now that DeepMind, Google, Elon Musk's AI company, started teaching DeepMind chess, those openings were found to be like completely bad and should never be used. So AI had a big influence on how chess is currently played. It made it like 10 times more boring, but yeah, people know how to beat bad openings now, thanks to DeepMind. Do you know that TensorFlow.js was made by a Macedonian Googler? I did not know that, so I like people like representing the Balkans in a good way, so good job. Are there any interesting projects Symphony is working on? Plenty, but I think that's something you should talk to our HR department or somebody else about. I'm not sure what I can speak about and what I can't. So yeah.
Okay, so if there are no more questions, speak now.
So no job openings? I'm not sure, honestly. You need to check the website.
Yes, go to our website.
No problem.
Okay. Should we wait for more questions? I think that's it. This was a really engaging chat. Many people asked, you answered a lot of questions. Glad about that. But we still have a quiz. You still have a chance to win some cool Symphony prizes we prepared for you, some gadgets. So stay tuned for for a couple more minutes, 4 or 5 maybe, and I will share my screen and you will be able to play the game. And as Slavica said before, after the meetup, you will get an email with a task to solve. You will have 2 days to solve the task to be up for the, as we call it, big prize. So, okay, I'm gonna share my screen now. You have to prepare your phones for this one. Can you see my screen?
Yeah.
Okay. Okay, you'll have to not help here because you know the answers. Okay. Just a second. Okay. So take your phones, please, and if you write Kahoot.it, you have to put in this code 467041, and you will be up for playing. Okay, so we're gonna wait till we have some players. For now, it's only Dule. Is that Dusan? Because I have a feeling that was Dusan. Okay, 5 players. Let's go. If you have ever been to one of our meetups offline in our offices, you know about our famous Kahoot quizzes. So 13 players, let's go. More. The prizes are really good. So 21, 22. So I would say you'll be the judge of how many players we want.
Don't put me in that position. How many do we have right now?
We have 31. Can you see my screen? 32.
Let's go up to 45.
45, nice. Ambitious. Let's go. I would say 76. Okay, no, 75. Okay,
Marima, could you please share the full screen? Because it's got...
Sure.
That's better. Cool,
okay.
Thank you.
Yep. Okay, 44 players. Really? You're waiting for the one? Okay, 45. Should we wait some more? Does anybody say something in the chat? Anybody has problems getting in?
No.
There's issues with he can't see the full screen.
Now he can. We saw that.
Okay. Okay, we're gonna start then.
Just wait for Nicola.
Nicola. Okay. Is Nicola there?
Oh, Love still can't see the full screen. I don't know what's happening. He's seeing the part of the list.
Okay. What about now? Because I'm
you can't see all of the names because still we have 45 or 50 people joining. So it's a scroll down menu. Don't worry, guys. Everyone is here.
Okay. How about this? I just full screened it.
Okay, I think start now.
Yeah, we can start now.
50 players. Let's go. If you paid attention to Bojan's presentation, you might kick this. Okay. 10 questions. I will not read them out so I don't confuse you. You have 30 seconds for each. Okay. What is machine learning? Follow the color and press the right answer.
Yeah, you will have the color and the button on your screen similar to the answer.
18 seconds.
People really paid attention to this. You see how fast they are answering.
Yeah, bravo, Bojan.
Yeah.
Yeah, you're an interesting speaker. 5 seconds, 4 seconds. Okay, people, we have 48 answers. Okay, somebody was too late.
And pretty much a lot of people answered it right. So
yeah, nice.
Cool, guys.
You listened. Who's Ma? Whoever Ma is, you are in the first place for now, okay? Next question. What is a model? 4 answers. I'm not going to read them out. I don't want to confuse you. Bojan, don't help out in the chat. I can't see it, but I'm telling you.
Yeah, don't worry. I don't even know the answers. So.
Okay, 30 right answers. Nice. First place, Nora. And Ma is right behind you. Okay, next question. What is supervised learning? $39 right questions. Let's see who's winning now. Nora still.
Nora is still leading. Nora, you're rocking it.
And Poison Mars Bars is right behind. What is classification? $35 right answers and the leaderboard. Let's see. Nora still winning. Next question. Okay, I'm not going to read this out because it's long and I'm just going to confuse myself, but you can see it up. Not everybody to answer this. 32 right questions. Let's go. Nora still winning. Poison Mars Bars right behind her. And okay, Vaka, third place. 6th question.
I like this logo though. It's so simple, I need to say. And on 5JS.
37 right questions. I'm sorry. The 8 of you.
No.
Poison Mars Bars is first. Nora, third place. I'm sorry, Nora. What platform did we use to create a new model? I think everybody will get this one. And pretty fast too. Okay, for all 45 answers. Okay, somebody actually did. First place, Poison Mars Bar. Still, who are you? Identify yourself. What front-end framework did we use in the demo? I think this was the 9th question. Okay, Poison Mars Bar still winning. Okay, this is the 9th question. What type of machine learning did we use in the demo? We already had that, right?
I don't think we did.
Oh, we didn't. Okay. Sorry, they just sound so similar to me. Two, what? Poison Mars bars. Still first. And the last question, the winner question, why does machine learning carry with it a certain risk in the future? Okay. So 3rd place, Nat. 2nd place, Vicky. And 1st place, Poison Mars bars, maybe? Poison Mars bars. Please identify yourself in the chat. 4th, Philip and Lazar. Sorry, guys. These are the winners. Thanks for playing. And please, we need to know who you are. So, Natasha?
No, it's Stefanovsky.
Okay, Natasha is Nat, I think. 3rd place.
Good job, guys. You did great.
And Adela is Vicky. Good job. We will contact you. Yep, your turn. Okay, great. We will contact you regarding the prizes. You will win some cool Symphony gadgets. And thank you all for attending. I hope you had fun. I hope you learned a lot. Bojan, do you want to have the closing word?
Yeah, thanks everybody for attending. It was kind of strange, not seeing the audience, but I feel like the chat was pretty active and I really had fun. So next time, I hope there's more people and that we cover something more in depth. But I hope you can learn, take the knowledge you saw today and make something cool. And if you do, share it with us. Thanks.
I want to thank you, Bojan, for having a great presentation and sharing your knowledge with us. I want to share a few more things with the audience. Besides the cool game we prepared for you after this, please check your email. We'll share also the presentation with you. We'll share the recording of this webinar so you can rewatch it, maybe think about it again, listen to Bojan's divine voice. Also, I saw that a lot of you asked about our job applications or positions in Symfony, so you can check our website always. We have a lot of open positions, and also you can reach out to us at hello@Symphony.is. So thank you for your attention. I hope that you had a good time, that you enjoyed it and learned something new, and see you soon. We will prepare a lot of new things for you in the future.
Thank you.
Thanks, guys. See you.